Okay, students, today I'll discuss frictional force in rotational dynamics. So it is also very important topic. Frictional force in rotational dynamics. So frictional force in rotational dynamics. So frictional force in rotational dynamics. So this is very different from linear dynamics, right? So many times people are thinking that frictional force always opposes the direction in which direction it moves. But frictional force in rotational dynamics is very much different from the linear dynamics. So now we are discussing today in detail how one can find frictional force in rotational dynamics. So in rotational dynamics, two cases can be there. So case 1, pure rolling, and case 2, slipping is there, right? So when an object be in pure rolling motion, then it has different way to find frictional force, and when it has slipping is there, that is, if when it is not in pure rolling, then there are different ways of finding out frictional forces there. So first I am discussing when the object is in pure rolling motion. So case 1. So when the object is in pure rolling motion. So pure rolling motion. So in this case, never apply Fr is mu times of n. So this is always wrong, is there, right? So many times people are applying the frictional force is mu times of n. So it is not the case as the case when the object is in pure rolling motion is there. So I'll discuss two things. One is direction, and then how one can find out the magnitude when the object is in pure rolling motion is there, right? So for direction, that is omega is the head of the department is there. So if omega increases, then positive torque means the direction of omega is supported by the direction of torque. If omega is decreasing, then negative torque. What does mean negative torque? Means the direction of torque is in opposite direction of omega, and when omega is constant, then no torque is there. So no torque because omega is constant, so angular acceleration will be 0, right? Let us take one example, it will make you more clear how one can search the direction. Suppose an object is coming in the downward direction. Suppose it is a cylinder is there, and it is coming downward. It is coming in the downward direction, right? And it is in pure rolling. So there is no slipping at the point of contact. It is in pure rolling motion, right? So there is no slipping at the point of contact. So if you draw FBT at this point, So one is frictional force, one is normal action, and one is mg is there, right? So see, the torque due to N and mg about the center of mass is 0 because both are passing from the center of mass. So there must be frictional force which is changing its omega, because at this point, since velocity is changing, or Vcm is equal to omega r for pure rolling motion, since the surface is at rest. So since the surface is at rest, so since Vcm keep on increasing, so omega keep on increasing, so there must be positive torque, right? So see, if it is coming in the downward direction, so the direction of omega will be this. So now frictional force, suppose it is this or this. Now I am deciding which frictional force, what will be the direction of frictional force is there. So see, omega is coming, this is anti-clockwise direction. So omega is anti-clockwise direction. And so I need torque should be also anti-clockwise because the value of omega keep on increasing. So torque should be also in the direction of, so that is frictional torque due to frictional force 1 H anti-clockwise and torque due to frictional force 2 H clockwise. This is clockwise. So I do not want clockwise because it should support. Hence, this is not the frictional force. The direction of frictional force will be the upward direction. So in this case, there is no surprising. That is obviously object is coming in the downward direction, frictional force is acting in the upward direction. Now let us take another case. Case 2. That is, if the object is moving in the upward direction, so object is moving in the upward direction, right? So this is moving in the upward direction, right? So the object moves in the upward direction in pure rolling motion. So now, after some time, it will be at this point, and then after some time it will be at this point. So after some time it will be in this time. So what is happening in this case? Vcm. So as it is moving in the upward direction, Vcm keep on decreasing. So omega has to decrease. So it should also decrease, right? So omega should also decrease. So again, we can take two directions of frictional force. So I was discussing when the object is moving in the upward direction. When it is moving in the upward direction, so after some time, the object will be at this point. So Vcm, this is omega. So Vcm keep on decreasing. If you draw MBT, then normal action and mg both are passing from the center of mass. So torque due to normal action and mg is 0. So there must be some another force due to which torque is responsible for the change of omega. So since Vcm is equal to omega r, so Vcm is decreasing, so omega is decreasing. it means what? Negative torque is there. Negative torque is required. So there must be frictional force, because the torque due to N and mg both are 0, because it is passing from the center of mass. So, and it will be negative torque because omega is decreasing. So that implies torque should be negative. That is in the opposite direction of omega. So omega is what? Clockwise. So in this case omega is clockwise. So clockwise. So torque must be anti-clockwise. Torque must be anti-clockwise is there. Right? Now if you take the frictional force, so it might be this or it might be this. Right? So see, the torque due to Fr1. So torque due to Fr1. So torque due to Fr1 is anti-clockwise. Anti-clockwise. And torque due to Fr2. Fr2 is clockwise. Clockwise. So since it is clockwise, anti-clockwise, so this is not there. So this should be anti-clockwise is there. So this is not acting, this is correct. So see, in rotational dynamics, if an object be in purely motion on an inclined plane, then the direction of frictional force is always in the upward direction. Whether the object is moving in the downward direction or upward direction. Right? So it is always in the upward direction in that way. Right? And if an object be in pure rolling motion on a rough horizontal surface under gravity, then frictional force is always 0. So if an object is moving, so VCM omega, so VCM is constant, so omega has to be constant, so frictional force will be how much? 0 is there. So when an object be in purely motion on a rough horizontal surface, whatever the value of mu, there is no any frictional force, provided it should have only under gravitational forces there. So students, I have discussed the direction of frictional force when the object is in purely motion. Now I am going to teach you how to find out magnitude of frictional forces there. Right? So how to find magnitude of frictional force in pure rolling motion. So what is happening, as I told you, in this case Fr is not equal to mu times of n, right? So Fr is not equal to mu times of n, right? So what I have to do? Draw FBD including frictional force. Second, write the equation F is equal to ma for linear motion and torque is equal to alpha for rotational motion. rotational motion by solving. So by solving the above equation, we get the magnitude of frictional force, right? So in the next video I'll explain this completely. So this is the series 1, and in the next video again I'll explain after that, and then I'll also explain you if the object be not in purely motion, then how one can find the magnitude of frictional force. Okay, thank you.